All right. Good morning, everyone. Let's get started. Thanks for joining us today. Today, we're going to be going through parametric formulas in Mosaic. We're going to be going through what they are, how they work, and how you can start using them in your products and libraries. Now, this is going to be an introduction to formulas. So if you're already writing advanced, complex formulas, you're probably not going to get a lot of information today. But, we will do a future webinar. We'll be getting into, the trigonometry formulas and that more complex stuff. So if you're just kind of getting started out in formulas and maybe a little bit intimidated by them, this one will be for you. So I'm Ken Roberts, and I'm joined by Matt Wallace, and you all know who Matt Wallace is. How are you this morning, Matt?
Yeah, doing great, Ken. How about yourself?
I'm doing good, thanks. So at the bottom or top of your Zoom screen, you should see a little button that says Q&A. You can drop your questions in there throughout the webinar, and we'll pause a couple times to answer as many questions as we can. So let's get started. So the first thing, I want to talk about is what are formulas? And formulas are just basic mathematical expressions or equations, essentially just basic algebra. A lot of people, they think that, parametric formulas are maybe a little bit out of my league or over my head, but a lot of the time that's not true. Most cabinet makers are already thinking in terms of parametric formulas. So if you've ever done a manual cut list and, you're thinking, how long does my top have to be for this cabinet? Well, you're calculating your cut list saying, okay, so I need my cabinet width minus the thickness of my left end minus the thickness of my right end. Well, that's a parametric formula you're doing in your head. So we're just going to take that same logic. It's just we have to type it into Mosaic so Mosaic can follow that logic. So let's take a look at the formula help document because it contains some useful information. Now I can get to the formula help document by going into any formula box. So if I grab this cabinet and I hit edit, and we go to the parts tab, and I grab one of these parts, I double click on it, I can see these little calculator symbols in these input boxes. Those are all formula input boxes. So I can control these values with formulas. If I click one of those formula boxes, it will open up the formula editor. Now, the formula editor, you have your main input at the top. So because I clicked on the width, it's asking me, what is the width of this part? So I could write a formula here. Below that, I have conditions. So we're going to look at this a little later on in the webinar, but this is a condition where I could say the width of this part is 24 inches, but if maybe the height of the cabinet is less than this value, then I could change the width to something else. So I can create conditions as well. And then below here is just a box where it's going to show you any conditions that you've added or formulas that you've added to this product. So while we're in this formula box, we have this blue question mark. Let's hit that. This is going to open up the formula help document. We go up to the top. Now going through this document is beneficial, gives you a pretty good overview of the formulas and how they work and how they can be used. Like for instance, first we have static numbers. So in my formula box on X, if I just put a static number, 150 millimeters, that means that that hole is going to be locked to that edge at 150 millimeters at all times, regardless of how much I stretch that part. Below there, you would have a simple formula. So let's say we needed a hole on the other side, 3 inches. Well, we would have to say part length, and this is a system variable. We're going to take a look at these at the bottom of this page. Minus 3 times Tom. So the 3 times Tom signifies 2 millimeters. When you're writing formulas, all values have to be input in metric millimeters. But if you wanted to write in imperial inches, you can follow that number with times Tom, which is essentially times 25.4. That's the conversion from inches to millimeters. Now, you're going to notice that in this formula, there are some parentheses, and that's because we have to isolate this specific expression here. If we wrote it like this down here without any parenthesis, this would mean part length minus 3 millimeters times 25.4. So it's going to times all of this by 25.4, which we don't want. So we're isolating this equation in parenthesis. So it's part length minus 3 inches. So, with the, it's similar to, PED math that you would have learned in high school. It's going to solve the bracket equations first. So the parentheses are going to be very important, and we're going to talk about those later on. And then you have some sizing. You know, if I wanted to add a part that matched the interior of my cabinet, I could do the H, so the height of the cabinet, minus my toe height. So now we're at the bottom of that bottom, minus my bottom thickness, minus my top thickness. And that just leaves the interior height in there. So that's another formula example. Below that, you start to get into trigonometry. So that's, you know, positioning and specifying lengths based on angles. So this is a little more complicated. But if you do want to get into that, and we will do a future webinar on this, these are the trigonometry formulas. So depending on what edge or angle you want to solve, you can use these formulas. Now, if we scroll down to the bottom, we get a list of all of our parameters. So first, these are our library parameters. So just like when you go in your library and you hit parameters, these are just all of these parameters where you can reference. So if I wanted to reference the top reveal on my wall cabinets, I would be able to use this variable, FLREV_TW. So these are the rest of the system parameters, your dados, your boring, your fasteners. Now down here, we have some reserved parameters. These are parameters that we can use to reference our positioning. So you have the width of your cabinet, the height of your cabinet, the depth, your rails and stiles. You have your scribes. There's that part length that we saw earlier. So that's just the length of the current part or the width of the current part. You have LE thick and RE thick, and that's just the thickness of your left end, right end. And then you have opening widths, heights, and depths. Those are for inserts. And then down here, you have the TOMM, which is our conversion to millimeters. Over here on the left, we have our thicknesses. So if I ever have to reference the thickness of a part, I would be able to type in that part name and follow it by .th. So this is kind of like a little cheat sheet there that you can use. Now, it is a good idea to, you know, maybe if you're just getting into formulas, maybe print this off, this bottom section off, and just keep it handy so you could use this to reference any variables that you need to reference. All right, let's jump back into Mosaic. Now, one of the most popular parametric examples are light panels. A lot of customers want, light panels they can place under their cabinet with parametrically controlled light grooves in there. So let's create one of those. I'm going to start off just by grabbing a cabinet. So I'll bring in a wall cabinet, and I'm going to edit this cabinet. I'm going to set the height to 3/4 of an inch. Now I'm going to tell Mosaic that we're not going to stretch the height on this. So we're going to turn off the height stretching so it's locked at that 3/4. I'm going to give this a unique name. I'm going to call this light panel with groove. And we'll get rid of that description. Next, I'm going to go to my face tab, and I'm just going to clear that out to make sure I have no door parts. And our interior tab will clear that out so we have no interior parts. Next, I'm going to come to the parts to build button. We're going to turn off everything except for the bottom. We'll say OK. Now, when I go to my size, this cabinet is 30 inches by 12 inches. If I look at my part, it's 12 inches by 28.5. So it's not sized correctly, and that's because it's still compensating for those ends. So I'll go to my shape tab. I'm going to grab that left end, and we're going to change that to nothing. We're just telling Mosaic there are no components on that edge. We'll also change that back to nothing. We go back to our parts tab. Now our part is following our part size. Now, if you're using dados, we may also want to add an override just to stop the blind dados from coming in. So you could just go to your dados, bottom into ends, and we could just lock that 0 there. Now we can go to the part. I'm going to double click on this part, and we'll give it a name, and we'll call this the light panel with groove. Delete that comment. And I want this panel to follow my door material. So I'm going to change the type from a bottom. I'm going to set it to panelized end. So now it's reading from my door material template. So now that we have that done, we have our panel ready. But I want to make this parametric. So technically, I could just draw some operations on the part, but they're not going to be flexible. And I want this to be a flexible component that I can save to my library and have it used in any job I need. So I'm going to go to the parameter tab again. And these are the parameters just for this product. So this does not come from your library parameters. It does not come from your job parameters. This is just product specific parameters. So let's think about the parameters we're going to need to control a light groove on a light panel. Number one, we're going to need to control the light groove width. So I'm going to add a parameter, LGW. And I just like to use acronyms for, whatever I'm doing. You want to avoid using, a parameter that already exists in Mosaic. You want this to be a unique number. And then I'll write a description. So we'll say light groove width. Now, I highly recommend writing descriptions for all of your parameters. When you come back in a few months, you can forget what these acronyms mean. So it's always a good reminder to just write a description. The next parameter I'm going to need is the depth of this light groove. So I'm going to create an LGD parameter, and that's going to be my light groove depth. And then I also need a parameter to position this light strip. I want to be able to control this and choose the spacing from the front of the light strip. So I'm going to create another parameter, light groove recess, and we'll add that description. And I'm going to specify from front. Now that we've created these three parameters, I can add values. So let's say my default values are going to be 3/4 inches wide, 1/4 inch deep, and 3 inches from the front. So let's remember these parameters. So now what we can do is we can go to our part. We're going to open up that light panel with groove, and we can either click the edit shape button, edit operations button, or we can just double click on the preview at the top, and that's going to open up the part editor. Now, we are looking at the top side of that panel. So I want to make sure I come up to my flip button and I flip this around so I can draw the operations facing downwards on the bottom. Now I'll go to my operations tab, and I have to decide what type of operation do I want to add to this. I could do a tool path, but tool path is just going to be your tool diameter. So that would be a little more complex to make that flexible. So instead, I could use a groove, which is essentially a dado. Now with the dados, the zero origin on a dado is this blue X, and you can see it works from the center of that dado. So we'll keep that in mind. So the first thing I need to do is I need to get this dado locked to this left side. I always want it to be on this left side. I don't want any gaps there. So with that groove selected, I'm going to come up to my coordinate inputs here. So I have the width, so that's going to define the width of this dado, the length, how long is that dado, the X position, and I can see the axis is labeled there. So on the X, where is this positioned on the X? And then our Y, where is this positioned on the Y? So the first thing I want to do is get that X locked to 0. So I'm going to come to the X formula box, and I'll change that to 0. Now, if I just put a value into this box here, I'm not locking it in. So if I go into a job and I stretch this, this may not be in the right spot. So I want to make sure I drive this with a formula. So instead of just putting my number into the input box, I'm going to come and hit the formula button, that little calculator symbol. Now I'd be able to just put 0 in here. Once I say OK, that field turns blue, which means that's now controlled fully by that formula. Mosaic is never going to change that now. Next, we have to think about the length of this. So I needed to just go, whatever length this part is, it's going to go across the length of that part. Now, remember, we had the part L and part W parameters. So let's jump to our length. We'll hit the formula box. And to reference that, I'm going to come down to my view parameters, and I'm going to hit the reserved button. And that's where I can come down and find those formulas. So on this part, the length is 30 inches and the width is 10. And I can see here, I need to drive that on the 30-inch edge. So I would use the part length. So in my length, I'm just going to type part L. We'll say OK. And that has told Mosaic that it's just going to follow the length of the part. Next, we have to control the width of this groove. And I can do that by using our light groove width variable that we created. And we have that set on 3/4 right now. And then next we have the depth. Again, we created a variable for that depth. So we'll use that formula box and we're going to say light groove depth. And that should change to 1/4 inch. And it did. Now we have to think about the positioning. So this is the front. So we're looking at the underside of this panel. So it's the front over here. So let's go into our Y. And I want to say part length So sorry, part width. We want to go across the width of the part. If I just put part width and say, okay, our dado is now locked to the edge, because remember, it's working on center. Now I want to go back that recess. So I'm going to say part width minus light groove recess. We'll say, okay. But so that's set to 3 inches. Remember, we set that to 3 inches, but it's 3 inches from the edge of our part to the center of the dado. I want that clearance to be 3 inches here and then that light groove. So I'm going to have to think about this. So part width minus our light groove recess, I need to subtract another half of that groove width. So I'm going to say minus light groove width divided by 2. Now, if I use this formula right now, it wouldn't work because I don't have it separated with parenthesis. So it's going to say part width minus our light groove recess, so 12 minus 3, we're at 9, minus our light groove width, 3/4, and then we're dividing all of that by 2, which isn't what we want. We just want to divide the light groove width by 2. So this function in here, I just have to surround with parenthesis. Now I can test this. Before I do that, if I take this formula and I test it, you can see that's going to equal 4.125. That's not the position we want. But if I surround this with parenthesis, so we have a proper formula, and we test that, now it's coming out at 8 5/8, and that's that position we want. We'll say, okay, it's moved back half of the width of that, and now we've created a light panel with a groove. Let's say, okay, and we can take a look at our panel, and you can now see that groove coming in there. Let me drag that 3D view over here, a little bigger. Now what I can do is I can go back to my parameters on that product, and I could make changes if I'd like. Let's say I wanted to push this groove recess back to 6 inches. I can simply just change that value, hit enter, and because that's driven by the variables in our formula, it's going to automatically. Let's say I wanted that groove to be wider. I could say, I want that groove to be 1.5 inches. It's going to change. If I wanted to increase the depth to 1/2 inch, I can do that there. So now we've created a product that we can save to our library and reuse over and over again in our job and have it be completely flexible depending on the hardware we're using. All right, let's say okay.
Hey, Ken, a quick question. Steve's asking, is there any advantage to using part length for the L versus using it for the Y? I think, yeah, go ahead.
So with the part length, they have specific axes. So this is going to be your length most of the time, the left to right. And then your part width is going to be your up and down. So if I use the part length on my Y, it's not going to work because it's going to be referencing this 30 inches, but in this direction. So probably, not something I would use. I want to use those appropriate formulas. Now, if I change the size of this, it's pretty easy to tell. So if we go to our operations and we let's flip that over, grab that operation, go into a formula box, that reserved. Now, if we go down, I can easily tell which one is the part length, part width. So that 8 inches, I can see that's following the part width. So if I want an operation to follow the width of that part, I would use the part W, not part L.
Thanks, Ken.
Yeah, no problem. All right, so we've got our light panel created. Let's say we needed a light panel with pucks instead. So I'm going to copy this product and we'll put another panel right beside there. Let's edit that. And we're going to go back. So we're going to go back to our product parameters, and I'm going to change these parameters. So for this one, it's not going to be a light groove width. It's going to be a puck light width. So we'll just kind of switch these over. This is going to be my puck light depth, and this will be my puck light recess from front. Let's change our description so we don't forget what these are. So we'll say puck light. I'm just going to copy that and we'll paste it onto these other ones. Now that we've got that done, we'll jump back to our part, double click on the preview so we can see that operation coming in. Now you can see my groove is down here right now with the 0 width because we've deleted those variables. So it no longer has variables to follow. So we're going to go to our operations. I'm going to delete that dado because we don't want a dado in this. It's not going to be a strip. It's going to be boreholes. I want to add 2 equally spaced puck lights on here. So first thing, I'm going to add a borehole, and that brings in a 5mm hole. So the first thing I want to do is I want to change the width of this, and I want it to follow that puck light width variable. So I'm simply just going to say the diameter of this follows whatever I have set as my PLW puck light width. You can see that's coming in as 1.5 inches now. My depth is going to be my puck light depth. Now my Y, similar to those light strips, we're going to go across the width of the part. So that part width, so the W, the L, I'm going to use the part W. So we're going to say part W minus puck light width. And we'll say, okay. So with that formula, it's from the front to the center of the light. Now we'll have to decide our X. So when we're placing these lights, essentially we want 3 spaces. I want a light here, so in section 1, and I want a light here. So we have 1 section, 2 section, 3 sections. So let's put that formula in there. So with our X, oh, let me put that back. Oops. Let me redo that. So we'll grab that again. We'll put our puck light width, puck light depth, and we'll get that positioning again. So that's going to be the part width minus puck light recess. So now for our X, I'm going to say part length. So take the entire length of this part divided by 3. We'll say, okay, that's going to put that in the position I want. Now the second one, technically I could say part length minus part length divided by 3. But a more simple approach is just I'm going to copy this. So up at the top, I'm going to hit the copy, the paste button. We're going to come over to the X, and we're going to say part length divided by 3. And I'm going to surround that with parentheses because I want to isolate that. I don't want it to affect the next expression. So part length divided by 3 times 2. We'll say, okay. And that's going to give us those 2 equal spaced pucks, equal distance from the sides and between each other. And then from there, we can say, okay, we can take a look at our product, and we have our puck lights coming in. And again, I can still go to that parameters, and I can make these changes. If I wanted them to be 3 inches, if I wanted to bring them closer to the front, I can do that. And you could get more intricate where you have parameters specifying the position, position from left, position from right. So you can get pretty intricate in there, but this would just be a basic product. We could save this to our library, and now we'd have a light panel with light groove, light panel with 2 pucks. You might want to do a light panel with 3, 4 pucks, depending on what type of jobs you're doing. All right, so we've got 2 light panels. Now, let's say I wanted to put like puck light cutouts in the top of my cabinet. Well, for that, it would probably be better for me to do this as an insert. Now, to take a look at the inserts, we're going to come up to the libraries. We're going to go down to inserts. Now, in the inserts, I'm going to choose which library I want to write this new insert in. Let's go with the lighting. It makes sense. And we'll add a new insert. And we'll call this puck light cutout 2 pucks. We'll say, okay. Now, in our insert, we have some tabs across the bottoms here. We have parts, where I could add parts if I wanted to add parts to this insert. Since this is just going to be light cutouts, we don't need parts. We can add operations, and we can add parameters. So just like we did with our cabinets, I want to develop some parameters for this. So we're going to do the same thing. This is going to be our puck light width. And we'll make sure we put that description in there. I'll copy that. And I'm going to add another one. This is going to be our puck light depth. Now you'll notice down here, there's a type drop down. Now this is where I could change what this variable is. Is it just a number? Is it a yes or no option? So like a switch. Is it an options list where there's multiple things to choose from? Or is it a quantity? In this case, this is going to be a number, so we're going to keep that on number. Then we need to add one more, and that's going to be our puck light recess. from front. Let's say okay. So now that we have these set, we'll just set in some defaults in there. And we'll say 3 inches from the front. Now we need to add the operations. So we can come to that operations tab. I'm going to add an operations by hitting the green button at the bottom. And then I get the insert operations page. So first we have to decide what type of operation in this. Is it a borehole, dado, or line bore? Well, we just need to bore some holes. And what side of the cabinet this is going to be on? Well, we want those holes to go into the top of our cabinet. We can reference the side. I prefer to work from the left side, left to right. And then we have our inputs. This is going to be our reference. So our inset, is this referencing from the front of the cabinet or the rear of the cabinet? We do want the front. So the first thing, our depth, we're going to use our puck light depth. Pretty easy. We're just going to throw that in there. Our diameter, this is going to be our puck light width. And then our inset is going to be our puck light recess. So we've added that hole in there. Now we just have to tell Mosaic, how far from the side does this puck light come in? Well, we can write a formula for that. So we'll hit the formula box. And for this one, we're going to use the open width variable. Now the open width, open height, open depth, they're only available for inserts, and we can see that by hitting our reserve parameters. And we can see them there. So inserts opening width, opening height, or opening depth. So it's just going to reference the inside dimensions of the cavity of your cabinet you put this in. So we're going to say open width divided by 3. We can say okay. So now we have that borehole, but we need the second light. So we're going to copy that. We'll grab it. We're going to edit. We'll head back to the distance to side. And again, I need to isolate this expression with parenthesis, and we're just going to add the times 2. Now you could make these formulas more complex if you wanted to reference your end thickness and your reveals. So, you can kind of get them centered on your door, depending on your design. You can get a lot more intricate with these. So let's say okay. And we'll drag in a wall cabinet. We're going to edit it. We'll go to the interior. And this is this section we're going to put it in because we want it to hit that top. So we're going to come down to our inserts button, lighting. There's that puck light cutout 2 puck we created. We'll drop that in. Let's take a look at our 3D view. And we'll turn off our doors. So I'll hit that layer button, turn off our doors. And we can see because we put that insert in there, it's bringing in our puck lights. And I can edit this by using the edit button down here. So with that insert selected in our interior tab, we're going to hit edit. That opens up the editor. I could switch to the parameters and I can edit my parameters here. So if I wanted this to be a 4-inch puck light, so I have to close down the 3D viewer, sorry. So we'll close that down, edit. So if I said, I want this to be a 4-inch puck light, I could change that there. And I want it to be 6 inches from the front of my cabinet on center. And that's going to make those changes there. So now you have a parametric insert that you'd be able to insert into your cabinets and control them custom depending on what hardware your customer purchased for that specific job. And you can create all different types of inserts. Maybe you don't want them to be in the top. Maybe you want operations in the bottoms or the sides. Maybe you want to bring in an additional part with that. So lots of flexibility in that inserts and formulas. So this is definitely something to kind of dig into. With formulas, I always say the best way to get a hold of them is just to practice and experiment. Once it starts clicking for you, you're off to the races and you're really going to start getting a lot of ideas where, you can make your library more parametric and flexible and reduce the amount of clicks you're doing on every jobs and, reducing the amount of customization.
Thanks, Ken. So on that note, let's try and shape a part with some formulas. So a common thing we see, people using undermount tracks. They want to notch out the back of their drawers for those undermount tracks. So I'm going to move over to libraries, go into drawer boxes. I'm going to grab this CNC dovetail drawer. You can see that this drawer here is set up to have a captured bottom. Let's go into high detail. So what we're wanting to do, oh, this has already been notched. Look at that. Let's try, let's grab a, yeah, I missed that part there. Let me just bring that back to, all right. Cause I think this is going to be how your guys' drawers are going to be showing up by default. So we're gonna have no notching in the back end. And I'm just going to show you the process to create that notch. So no notches here, just a fully captured bottom. My bottom is recessed a 1/2 inch up for that undermount track. So we're going to click on the drawer back. Now we're in the shape tab. Here's the operations. This is going to be an actual shape. So I'm going to place a point by just selecting the line, and I'm going to add a point. And now I want to drive this point with a formula. So I'm going to click the point, and I need to move my x axis. So we're going to click on the x, and I'm going to make this the drawer side thickness. So now that point will always be, if I was to change the material on this drawer, this notch is always going to stay, where that drawer side thickness is. If I go to 5/8, it's going to move to 5/8. We're going to add another point. This one, I'm going to move to drawer side thickness plus, and we're going to say 1.75 times 2 millimeters. So now again, that point will always stay, 1.75 in plus the additional drawer side thickness. Now I'm going to add 2 more points. And a lot of times I like to just grab these points and sort of get them in the area that I want to go. Now the shape editor here is pretty slick. It's going to snap to 90 degrees. So you can see it's kind of snapping to the points there. But I need to make these also parametric, because if I was to stretch this right now, these nodes would not stay in the proper position. So we'll do this one first. I'm just going to copy the X axis. So I'm just Control C, and we're going to pop this into this one here. Now my height, I need this to follow my drawer bottom recess, which I know is 1/2 inch. So we're just going to set this to 0.5 times 2 millimeters. This node here, we're going to copy that one. And we're going to paste it into here. And then my height. Now, like Ken mentioned, it has to be in metric. So you do the times to Tom, but just to show you, you could just put the metric value in there as well, and it would bring you to the same point. Now we have that first point placed. We're going to add a couple more points. I'm going to add 1 more point. This one here is really going to be the same formula that we have here, except we need to add the part length to that. So we're going to click on our X, and we're going to go part length minus drawer side thickness. I'm going to save some time and just grab this point here, and I'm going to copy this formula. We're going to place another point. I'm going to paste that formula back into the X location, but I'm going to add part length. We're subtracting the drawer side thickness, and we're subtracting an additional 1.75 inches. So again, I'm going to place 2 more points, drag them up into their locations, and we're going to copy those formulas, paste them into the points. Again, make sure that my heights are set locked to 1/2 inch, so 0.5 times 2 millimeters. And this one's going to be part length minus drawer thickness. Part length minus drawer thickness. And our Y is going to be that 1/2 2 millimeters. Okay. So now I can stretch test this. If I just click off of the point, I have this option here to stretch the width and the length. Good idea to test this because, we're all human. We make mistakes. There may be an error. Maybe I didn't lock a formula correctly. So if I stretch this, I can get a visual that those nodes are staying, no matter what the size of this part is doing, it's staying in the correct spot. You can ignore the data that's being driven by some formulas in the back end of the software that's being controlled by your parameters for the drawer box. What we're looking at is the shape. I'll also point out that you do have the option here to anchor the points. So, I could technically anchor these points like into the corner. This works well, but the formulas are going to override those anchors. I've always found that formulas are the better, driving factor when you're trying to place points or for operations. But that is a quick way to add some points as well. Just keep an eye on it. All right, yeah, so we can look at that now in 3D. I'm going to go back into high detail. And we can see the back of that drawer now has that notch. All right. Now, another common thing we're starting to see more is people doing full tops, but they're doing a cutout in the top of their cabinets. So there's a few ways we could do this. We could add this at the part level, but we'd have to do that for every part. The other option is to add it as a part template. So part templates you're going to find under libraries, hardware. You're going to go over to fasteners, and you're going to find the part templates. Before we get into here, though, I need to add some user added parameters that I can reference for my cutout options. So instead of doing this at the product level, like we did with the pucklate bottoms, I'm going to do this at the job level. Now, you could save this globally so that you have these parameters available to you for future jobs. But for today's demonstration, I'll just do it at the job level. So we're going to go to Edit Job Parameters. I'm going to tab over to the Other category. So when we get into the Other category, you'll notice any of these other categories, this area right here is grayed out. Okay, so there's no options here for adding user added parameters. We have to move into the Other category. So I'm going to add some parameters in here. My first one is going to be for my top cutout side inset. So I'm going to call this top cutout side inset. And like Ken mentioned, we really want to make sure that we put a description here so we know what it is. So it's the top cutout side inset. I just need this to be a number. We have some, value ranges here. I'm just going to leave it at 0 for max and minimum values. And the side inset, let's set that to 4. I'm going to add another parameter. This one is going to be the top cutout front inset. So TCFI. Call this top cutout front inset. Again, it's just going to be a number. And I'll set that to 2 inches. Let's add another one. This one's going to be the top cutout back inset. Call it top cutout back inset. Again, that'll just be a number. And we'll set that to 3 inches. Now, one more. I'd like to add an option to turn on or off this cutout. So we're going to add one that's going to be called top cutout yes or no. So we'll call it TCYN. I'm just going to say top cutout yes or no. Now, instead of this being a number, we're going to change this to a yes no option. Okay. And I'm going to default this to yes. I'm going to explain this a little bit more when we get into the hide options inside of our formula. So we're going to hit OK. And now we have those to reference. So we're going to go back into the libraries, go into hardware. I'm going to go into part templates, and let's add a part template. So I'm going to click new, and we'll call this top cutout. Once I hit OK, I can see all of my parts. So there's a drop-down menu here. It's going to default to the base cabinet, which is what we need today, but you have options to add these to any other of your types of cabinets. We're going to be working with the top. So if I select the top, click Edit, I now have an image of my part. So we're going to add a toolpath, and we'll just do a closed toolpath. I'm going to just work on placing my points first. So let's grab the first point and I'm going to work on my x-axis. So that is going to be our TC top cutout side inset. And the Y is going to be the top cutout front inset. This one here, my X will be top cutout side inset. And for my Y, because I put a back inset, I need to go part width. So we're going to say part width minus top cut back inset. My Y for my right side here is going to be top cutout front inset. The X, now we need to reference that part length. So we're going to say part length minus top cutout side inset. Same thing here. So my X is going to be top part length minus TCSI. And finally, my Y on that one is going to be the part width minus top cutout back inset. Okay, so now my points are placed with those user added parameters. I want to add now a like an automatic sizing. So let's say like this cabinet was to shrink down like past say 12 inches, and I have my rails set, you know, too large that they're going to collide with each other. So I want to set, you know, kind of like a fail safe and just make sure that that my points, my X points are going to automatically size to an appropriate size. So selecting the node here, I'm going to select the X, and we're going to add an if statement. So we're going to say that if the width of the product is less than 12 inches, then our X needs to be 2 times to millimeters. And we're going to add that formula. So I need to do the same thing here. So if width of product is less than 12 times Tom, then X equals 2 times Tom. And we're going to add that formula. My X position here, again, if the width of the product is less than 12 times Tom, then X, now this one here, we need to reference the part length. So we're going to say less is part length minus 2 times millimeters, TOMM. I'm going to put that in brackets. We're going to add that formula. Do the same thing here. If width is less than 12 times Tom, then X is part length minus 2 times millimeters. Oh, I almost missed the T there. Let's put that in. So add that formula. Lastly, we need to set the depth, and we need to select a tool. Now, if I was to select a tool and set a depth to this, I could use, there's a few different variables we could use here. We could use part like top dot thickness. We could say, you know, the part thickness, but I also would have to account for the diameter of the tool. So right now we're going to be cutting on the center line of this machining line here. I could add that into my formula to account for the diameter of my tool, but I want to show you guys a quick trick. We're going to hit OK. We're actually going to head over to the optimizer, and I'm going to create a tool group. So we're going to go to CNC tooling, panel tool groups, and I'm going to add a tool group. We're going to call this inside cutout. Oh man, I can't type today. Inside cutout. Now my outline cutter is my 3/8 compression, so I'm going to add this in. I want this to always do a through cut. I don't care what the thickness of the material is. I always want it to do a through cut. And I want, right now we're working on the outside of that line. So my offset needs to be the diameter of the tool to be on the inside of that line. I'm going to hit OK and go back into my hardware, part templates. I'm going to grab that top and edit. And now I can select that tool path. And when I select a tool, instead of grabbing just a regular tool, I'm going to grab a panel tool group and I'm going to grab that inside cutout. So I don't have to set a depth here because the depth has been assigned to that tool group and I'm working on the inside of that line. So I don't have to account for the offset of the tool. So we're going to hit OK. And I'm going to bring that. It looks like I might already have had that in my parameters. So look here. So in the parameters under fasteners, yeah, you're going to have to grab it right here. So we have the top cutout set up for the CNC panel fastener template. So I can see that my top cutout has come into my base cabinet. If I bring in any of these base cabinets, we can see that one's got a high detail. But if I bring this one in, you can see it's doing the cutout on all of those cabinets. So let's open up this cabinet and have a look. And let's bring in some parameters to control that. So we're going to go over to the other category. I'm going to grab all of these parameters. We're going to hit OK. So I can modify these now at the product level. So if I turn this to no, I forgot a step. Let's go back into the hardwares. So we're going to go to part templates, go back into the top. Apologize, guys. We need to now give it a hide option because we added that variable, but we haven't actually given it a hide command. So all I need to do is click one of the points and we're going to go to the hide option here and just click on the calculator. Now, this is, there's some things you need to know. 0 is going to show the operation. 1 will hide the operation, but also 0 equals no and 1 equals yes. So we have that yes, no option. So depending on what we pick, it's going to be a 0 or a 1. Okay. So to hide this, we're going to say that we want to show the operation by default, right? But if our variable of TC, yes, no, so top cut, yes, no, is equal to 0, then we want to hide. So basically if TCN is saying show, right? We want to hide that operation. So we're going to add that formula, hit OK, hit OK. We go back into that, come into parameters, go to the 3D view. So you can see here, if I turn it on or off, I can now control that formula. If I size this, let's go down to 12 inches or 11 inches. Look at that. So we've made a mistake. Let's have a look. So let's go back to libraries, hardware. We're going to go to part templates. I'm going to click on my top because I've missed a step on one of these points and it's going to be my sizing point. So let's go back to the X and that one looks good. So we're part width. Yep. Have a look at this one. Okay. I see the problem. So let's grab this and edit this. So see this, we have if width is less than 12. Well, we need to add that 12 times to millimeters. And let's update that formula. Hit OK. Hit OK. And there you go. Let's open that back up again. Back into 3D. So you can see it's automatically sizing those rails down to 2 inches. If I bring this back up to like a 36, it's bringing it back to 4 inches, but I have full control over these. So if I want these to be 6, I want to be them 2, 5, 5, 5, or turn them on and off. So it gives you a nice control over that cutout.
Awesome. Sorry to interrupt, Matt.
Yeah, no problem.
Mike has a question. Would we be able to turn off that operation for cabinets once they go under 12 inches?
Yeah, so you would do the same thing under libraries. So we're going to go back to hardware, part template. We're going to edit this. So you would change the hide option here, or you'd either change it or you'd add an addition. So what we would say, let's edit this. So if width of product is less than 12 times to millimeters, then we want to hide, right? So we're going to hide that operation. So right now, and we'll update that formula. So yeah, right now we're showing the operation. So 0 is will show, 1 is will hide, right? So hit OK, hit OK. And now if I was to change the width of this guy to 11 inches, it's going to hide that operation.
So, does if anyone have any questions, feel free to ask them. Just add them in the Q&A there. All right. Yeah. So that's yeah. Sorry. Go ahead, Matt.
Oh, I was gonna say I'm seeing this more and more. You know, my shop we always did just stretchers and stuff, but I have, you know, I know that we've seen this request for these top cutouts, and same with the scoop backs, the puck lights. Man, that's a real popular one. To have these come in as separate items. So,
yeah, one thing I also want to touch on too, if you're creating these panels, you may also want to go to your info tab and the snap to. So we may just want to have these snap under our wall cabinet. So if you're doing a wall underhang, that can also be a handy option for you. So when you do drag those from your library into your job, they do snap to the elevation that you'd prefer.
Yeah, for sure. Travis is asking same concept for vertical dados for lightning, and absolutely, you would just you could actually do it as an insert. You could do it as a part template, like I just showed you, or like Ken showed, you could go in, create a cabinet that's that's one off for your library that you just saved to your library. Add those operations to your left and right end, and then you have control over the parameters with those user added parameters.
And then Edwin has a question. Would this be the best for outlet behind cabinets? Yeah, you'd probably want to use a part template for that. Technically, you could come in and draw those operations manually on your back, but then you're going to have to put that on every single cabinet. So that can be a little overwhelming. So you may just want to create that part template like Matt did for the top cutout. You would just assign that cutout to the back instead and maybe have some positioning variables. And then you'd be able to grab that individual product parameters, and you would just load that fastener, panel fastener. You would only load that into the cabinets where you want that cutout to come in. So that's how you could just, do it once, and you're going to be able to assign that to individual cabinets. And Sahaj has a question. I am working on a very complex door. It has no profile, but a lot of diamond-shaped cutouts, pockets. How can I make that parametric? How can I use formulas on that? So something complex like that, Sahaj, there's not going to be a quick answer for that. So you're really going to have to plan out how those operations are going to come in. You may have parameters for your offsets, so at least they're automatically spaced. You may, how far you want to go into it, you may have hide operations on each of those cutouts. So as your doors stretch or shrink, certain cutouts disappear or reappear. So probably not something we can go over in a webinar. That's pretty complex, but you can draw it in Mosaic. Or, sometimes if it's something really complex like that, where we're doing, arrays of complex shapes in a cutout, we may want to use, a V carve. There are softwares that are more appropriate for the highly customized stuff. You can still do, formulas and parametric designs in Mosaic, but some of that complex stuff is going to be very time consuming.
And Carol is asking about optional light screws into shelves or ends. So yeah, it's kind of the same sort of thing. You could add like sometimes I'll add it's not a fastener, sorry, an insert, but we'll add let's go. What would be the best way to show this quickly? Well, we'll go back into inserts. So you could a um, add something to your operations. So say we wanted to add a dado, right? The dado is going to be based off of whatever opening height you have. So a lot of times, like if you have an open cabinet that has like say a few adjustable shelves, an insert's only going to put that insert on whatever opening you place the insert. So a lot of times I recommend, put it in either the top or the bottom, but set up a parameter to oversize the length of it. And then you can just add that value to that parameter to make sure that it's coming in on the sides of the cabinet. Or again, add them as a panel fastener and just have them driven by your own parameters for sizing the depths and the widths and the lengths.
All right. And Mike says, couldn't you use inserts for outlet cutouts, one for base, one for wall? Yeah, you could absolutely use inserts to put your cutouts. It's just sometimes you have situations where you already have an insert in that opening. So you wouldn't be able to double the inserts. Technically, you could draw the outlets on that existing insert, but you could be getting into the weeds there a bit. So depending on how, what type of design you're doing, yeah, inserts can be a great tool for cutouts as well.
And advanced formulas, Travis. Yeah, we're going to be, it'll be next year. This will be actually, we're getting close to the end of the year. So this will be obviously the last one for this year. But we are going to be picking this up again next year. Hopefully, we have a few other topics we'd like to do, sort of these entry level or, introduction to. And then we're going to start moving into that more intermediate and advanced sessions.
And then Steve asked suggestions for removing screw pilot holes from front area of unfinished ends in sink cabinets and cabinets adjacent to dishwasher steam moisture damage. For something like that, Steve, you may just want to create a unique fastener with those specific holes that you want to remove just turned off. That's probably going to be the most straightforward method. And then you could just override your fastener on that specific cabinet when you come into that scenario. Jeff asked, where can we see the recording of this webinar to go through all of this again? So Jeff, you can find that on the Mosaic YouTube. It's going to be posted on there. It's also going to be posted on the Mosaic forum. It'll also be posted on the Mosaic training video page. So a couple places you can go view that. The easiest one, help training videos. That'll open up the training video page for Mosaic. And if you scroll down, there is a webinar section. So if we scroll down past these videos and we get to this section, you have the webinars with Matt Wallace and Ken Roberts. So the formula one is going to be posted here, but you could also get that directly from the YouTube page as well.
Mike, love the suggestion. We will definitely take that into consideration. That's a good topic to cover. And that's the fastener template topic, if anyone's wondering.
All right, and Brittany, for adding an extra part to tray pullouts, like a tray finish face, easiest to add an insert of extra part with formulas to have it sized correctly, no matter the size. If you're talking about like a pullout tray drawer, you would be able to add a face directly in the drawer box settings. So just to show you that, if this is what you're referring to, so libraries, drawer boxes, you would come in here and you would grab a tray. So let's just grab a standard tray. And if we look at this tray, it's just a regular drawer box right now. But I could come and select the 6-piece tray checkbox. Once I select that, that gives me a tray face and I can add adjustments on here. So maybe I want an extra 1/4 inch on the top and I want an extra 1/8 on the sides. So I'd be able to input those values in there, say, okay. When I view that product, it now has a 6-piece, which is our finished face, and that is going to stretch automatically into the opening that you're putting it into. You may also want to make sure you do have a tray inset adjustment. That's going to push that tray into your cabinet to make sure you don't have any collisions with your drawers. If you're talking about a pull-out tray insert, for that, you would have to go into your inserts library and you would have to manually add those parts. So you would select the, whatever library you're using. And then in your parts tab, you have all of your pull-out parts in here. So you could add additional parts and reference the open width, open height, open depth to build in those formulas. But I think you're talking about pull-out trays. So I think the drawer answered that question. And Jeff says, you guys are awesome. Thank you. Thanks, Jeff. Thanks for attending. And
Thanks,
hopefully
Jeff.
this is handy, and definitely stay tuned for the future webinars. We'll be getting into some more advanced stuff in the new year. Yeah, you're welcome, Brittany. All right, everyone. Well, thank you so much for attending today. Stay tuned for the future webinars. We really appreciate everybody. We hope this was helpful. And we'll be posting this on the YouTube and the training video page, and you'll be able to view it there whenever you like at your convenience.
Thanks, everyone.